So the next source of clean energy is going to be wind. It's the use of wind turbines to turn electrical generators. And it said that in the next 50 to 60 years, wind power could meet 5 to 10% of the US electricity demands, which is a pretty high percentage. The only drawbacks is that needs technical advancements because there's a lot of noise pollution that comes along with these fields of wind turbines and the cost of large tracts of land. So they take up a lot of room that could possibly be used for populations. Here we can see what that looks like exactly. So we have a bunch of these wind turbines all over this field as far as we can see. Again, these are making a lot of noise, so there's nothing really else that this land can be used for other than the wind power. Here we have a diagram of what it looks like inside of one of these wind turbines. So we have the wings here and the propellers that are going around. And then it's attached to a gearbox, which is attached to a generator. And the generator turns electrical controls, producing electricity. Hydroelectric power is another form of clean energy. It's the power of falling water to drive turbines that produce electricity. So this is the Hoover Dam is an example of hydroelectric power. These large dams allow for controlled flow of water. The water reservoir behind the dam creates this difference between the heights. So the water is going to fall from a significant height, producing electric power by turning electrical generators. The only drawbacks are that they have finite lifetimes, so there's going to be a lot of sediment that builds up behind these dams, and eventually it's not going to be usable. And finding suitable locations, so it's pretty rare to find a dam that, or a river or a waterfall that is suitable for a dam, let alone one that we haven't already used for this purpose. Here we can see what that looks like, a little diagram where the water built up behind here. We have an opening. The water is going to flow down through the dam, falling down here. It's going to run into the turbine, turn the turbine, which is going to turn a generator, and it's going to produce electricity. Geothermal energy is harnessed by tapping natural underground reservoirs of steam and hot water. The easiest way to understand this is just to take a look at this diagram. So there's a lot of hot water, or not a lot. There are these sources of hot water underneath the earth that we can drive down into. All that hot water is going to come up, produce steam. Once it's decompressed, that steam is going to be used to turn an electrical turbine, producing electricity. Then there's going to be a secondary part where the water is cooled again and then injected back into the underground well. The drawbacks to this is that it's not unlimited, so those water sources eventually aren't going to be able to be used anymore because we can't recharge them. We're cooling off the water every time we put water back into them. They last anywhere between 10 to 15 years per individual well. And they can't provide a huge amount of energy for the world, unlike wind, nuclear, and solar. Tidal energy is also a very limited source. It's not very economical if the tidal range is less than 8 meters or if it's too narrow of an enclosed bay. It's not able to produce a whole lot of world energy as well, but basically what tidal energy is it's energy from the ocean. Here's a diagram, much like the dam. What we're going to do is we're going to wait for high tide. This is going to be open. Water is going to come through. And then we're going to close these barricades here. And once low tide happens, we open up the barricades. The water comes through, turns these turbines. Those are going to turn the electrical generators producing electricity. Okay, we're going to come back to this in just a moment.